Section 5.2, Polynomials and Polynomial Functions. Well, what is a polynomial? You actually have already worked with polynomials, we just haven't called them that yet. So, we have three specific types, and then past that we just call it a polynomial. We have a monomial, which has one term, a binomial that has two terms, and a trinomial that would have three terms. So a polynomial is a monomial, or an expression that can be written as a sum of monomials. So all we're doing is putting things together by adding and subtracting. So what is the degree? The degree of a monomial is the sum of the exponents of all the variables. Make sure you highlight variables. So we're just going to sum the exponents of the variables to find the degree. You'll talk a lot more about the degree in college algebra. Right now we're just going to touch on what it is. Now the degree of a polynomial is the greatest degree of any of the one terms. So make sure you just look at the biggest one, and that's your degree when you're trying to find the degree of the polynomial. So, find the degree and state if you have a monomial, a binomial, or a trinomial. Number 1 has negative 10 xy to the fourth. You actually only have one term. There are no plus signs or minus signs breaking that up into more than one term. So, one term would be a monomial. Now, how would we find the degree? The degree is taking the sum, right? The sum of the exponents of the variables. So x has a power of 1, y has a power of 4, so 1 plus 4 is 5, so the degree is 5. On number 2, we have 4x cubed plus 2x minus 5. 4x cubed is one term, 2x is another term, and negative 5 is the last term. So we see we have three terms. Three terms is called a trinomial. Now, because we have three terms, the degree comes from the highest one. Well, let's look at the first term. The first term was 4x cubed. Its variable had a power of 3, so the degree of that term is 3. In the second term, x has a power of 1, so the degree of the second term is 1. Now look at the last term. The last term does not have a variable, so its degree is 0. I agree that 5 has a power of 1, but the degree comes from the variable. There is no variable, so the degree there is 0. So what's the highest? The highest is 3, so the degree is 3. Looking at number 3, we have 2/3 xy minus 5x cubed y to the fourth. How many terms? One term, two terms. So since we have two terms, this is considered a binomial. Now looking at each term individually, what's the degree of each term? Well, we have x has a power of 1 and y has a power of 1, so the degree of the first term is 2. In the second term, we have x to the third and y to the fourth. Adding those together, we get a degree of 7. So now we just pick the greatest one, and the greatest is 7, so the degree is 7. Add or subtract and write in descending order. Parentheses 12r to the fourth minus 5r squared plus 8r minus 15, plus in the next parentheses we have 7r to the fourth plus 3r squared plus 2r minus 9. With the parentheses, some students think they want to multiply, but you're not, because what's in between the parentheses is a plus sign. So really all you're distributing to that second parentheses is a plus sign. So why do they use parentheses to begin with? They're just showing you that there's a first polynomial and they want you to add it to the second polynomial. So dropping off the first parentheses, we have 12r to the fourth minus 5r squared plus 8r minus 15. We should distribute the plus sign, but when you distribute a plus sign, nothing changes. We're going to have plus 7r to the fourth plus 3r squared plus 2r minus 9. And then all we have to do is combine like terms. Like terms have to have the same variable raised to the same power. So we do have some r to the fourth, and that's going to turn out to be a 19 r to the fourth. Remember, when you add or subtract, you don't change your powers. You just add or subtract the numbers in front. We have a negative 5r squared plus 3r squared, which gives me a negative 2r squared. We have a plus 8r and a plus 2r, which gives me a plus 10r. And then we're going to have a negative 15 and a negative 9. Those are the same signs, so we add and keep the sign, which gives me a minus 24. So our answer is 19r to the fourth minus 2r squared plus 10r minus 24. Number 2, parentheses 4x to the third minus 3x plus 4 minus, in the second parentheses, 3x plus 6x cubed minus 5. The first parentheses we can just drop. There's nothing to distribute. It's just saying, hey, here's the first polynomial, which is a trinomial because there's 3 terms. In the second, we do have to distribute the minus to get rid of the parentheses. A negative times 3x is a negative 3x, so minus 3x. A negative times a positive is a negative, so minus 6x cubed. And a negative times a negative is a positive, so plus 5. At that point, be very careful when you're combining like terms. They're not in the same order. So we have a negative 6x cubed and a positive 4x cubed. Different signs, so we'll subtract and keep the sign of the larger, so we get a negative 2x cubed. We have a negative 3x and a negative 3x. Those do not cancel each other out. They're the same sign, so we add and keep the sign, which gives me a negative 6x, so minus 6x. And then we have a positive 4 and a positive 5, which gives me a plus 9. So the answer is negative 2x cubed minus 6x plus 9. I'll let you do number 3, but I will give you the final answer. It's 4x squared y squared minus 16x squared y plus 8xy squared. Descending order is a little bit harder on those problems, so don't worry too much about descending order. But for the ones that have one variable, definitely need to put it in descending order, which is what the direction was asking for. Write an expression for the perimeter in simplest form. You might know the formula for perimeter, but if you don't have to, because perimeter is just walking around the object and adding up all the sides. So remember, when you're talking about perimeter, just walk around the object and add up the sides. Well, if this side is 3x plus 8, then the opposite side would also be 3x plus 8. And if the left side is x minus 3, then the right side needs to be x minus 3. So walking around that object and adding up all the sides will give us the perimeter in simplest form. So we'll have 3x plus 8. Walking around, we have to add x minus 3. Continue walking, we have another 3x plus 8. And continue walking, we still have another x minus 3. So then we'll just combine all like terms. All of our x's get put together. So 3x plus 3x plus x is going to give me an 8x. And all of our numbers are also going to have to be put together because those are like terms. 8 minus 3 plus 8 minus 3 is a plus 10. So the perimeter in simplest form is 8x plus 10. There is a formula, and the formula for perimeter is 2L plus 2W. So if you want to use a formula instead, you still should get 8x plus 10. And the reason being is you'll have twice the length, which is 3x plus 8, plus twice the width, which is x minus 3. Distributing in your 2 times 3x is 6x, and 2 times 8 is 16. Distributing the 2 there, we get a 2x minus 6. Putting those like terms together, we still end up with 8x plus 10. So you can use a formula or just add up all the sides. The next part of this is an introduction to functions. You can also view polynomials in a function notation. If you haven't seen function notation before, let's go over it in depth. When you have this form, you have f of x. That is not being f multiplied by x. That is f of x, f evaluated at x. They stay together. You never can separate those. So when you talk about a constant function of f of x equaling c, you're saying something like f of x equaling just a number. So f of x would equal 2. Now, hopefully you understand that f of x and y is really the same thing in that direction. If you see f of x, you can think of it as y. So we have, in a sense, y equals 2. You know what kind of line that is. If I asked you to graph it, that would be that horizontal line of y equaling 2. You don't need to know all that quite yet, but I do want to go over the fact that we have seen these before. Now, looking at a linear function. A linear function is still going to be that f of x equaling mx plus b. So f of x, we can consider it as y, and y equals mx plus b. You've seen that before. That's the equation of a line. So for example, y would equal 2/3 x minus 5. We've seen linear equations before. Now something we haven't worked with too much in this class yet is quadratic functions, but we will. So for a quadratic function, you're going to want to see an x squared. And again, f of x stays together. You can look at it as y, so y is going to equal ax squared plus bx plus c. We're going to learn how to graph those things, which are parabolas when we graph them. But an example would be y equaling 2x squared plus 6x minus 7. So that's an example of a quadratic function. Again, a quadratic function would have the function notation f of x, f of x, f of x. So we kind of talked about what f of x is. It's just your y, but staying in function notation, it is f of x. So the last part of this is to be able to add using function notation. So given f of x equaling 8x plus 3 and g of x equals negative x plus 3, I want us to find f plus g and f minus g. First, let's point out a few things. F of x is function notation. F of x equaling 8x plus 3 is just a linear function. It matches the f of x equaling mx plus b. G of x is also a linear function because it also matches up with f of x equaling mx plus b. Now when they want you to find f plus g, they've kind of shortened the writing of f plus g. This is really f of x plus g of x. So what that means to do is take your f function, which is 8x plus 3, and add your g function. And your g function is negative x plus 3. These really should be in parentheses to show that here's my f function and here's my g function. But you're not multiplying, you are just adding. So looking at the first parentheses, we don't need them. In the second parentheses, just like we did on the previous problems, we distribute a plus sign to get rid of the parentheses. A positive times a negative is a negative, so minus x, and a positive times a positive is a positive, so plus 3. Then we just combine our like terms, so we end up with 8x minus x is a 7x, and 3 plus 3 is 6. So f of x plus g of x is equal to 7x plus 6. Now, they've also asked us to find f minus g. So f minus g is going to equal f of x minus g of x. We'll do the same exact thing. What is f of x? It's 8x plus 3. We'll put it in parentheses. Minus, what is g of x? It's negative x plus 3. The first parentheses don't need to be there, so we'll drop them off. So 8x plus 3. To distribute the minus sign, and negative times a negative is a positive, so plus x. And a negative times a positive is a negative, so minus 3. Combining like terms, we have an 8x plus x, and that's going to give me a 9x. The positive 3 and the negative 3 actually cancel each other out. So f of x minus g of x is just 9x. So don't make this any more challenging than it needs to be. You're just adding polynomials, but to do so, they put it in a function notation. So just add your polynomials, which means adding your like terms or subtracting your like terms.